Okay. Welcome everybody. Again, my name is Esther Herr. I'm with CCIJ. And as many of you know, we are a mighty organization that is about convening and leading global investigations that are grounded in strategic mentorship. And we use data, we use visuals, and we use good storytelling to be able to present some very robust stories that is all about accountability and is solutions driven. That is who we are. We provide a variety of different things, including trainings, which is why you are here today. I am so pleased to introduce to you Juan Pablo Marín Diaz. He is the founder of DataSketch. And I'm sure he'll say a little bit more about DataSketch, but it is this amazing organization that provides so many different services, whether it be reports and interactive reports and dashboards, data strategy, customized apps, and trainings. And we are a recipient of one of the many trainings that he and his team offers. I'll drop the DataSketch website in the chat box momentarily, but without further ado, I want to go ahead and hand it over. Thank you.
Thank you, Esther. Great meeting you all. I'm very happy to be here and share some of the experiences we've had with working with data. I hope they are useful for your work. Let me share my screen. If you have any questions at any point, feel free to open the mics and just ask. Great. All right. So we're going to talk about data structuring. This is a very important topic, and I think it's easily overseen or skipped in trainings. When we talk about data journalism or data visualization, comes up as the first topic that sounds relevant. But in order to do data visualizations properly and to structure your projects around data properly for your investigations, it's very good to have a broader overview of what it means to organize and collect data. Okay, so I'm myself, I'm a data scientist. I'm based in Bogota, Colombia, and I founded DataSketch. It's an organization where we use data and software to help smaller newsrooms to basically leverage their data. And so organizations that do not necessarily have access to designers or coders can improve how they interact with their own data, and they can build better tools for other organizations. Okay, so well, basically we may think that data and algorithms will solve all of our problems, and it might be the case, you know, given the recent advances in technology. All we need is to collect some data. Let me just make this bigger. We need to collect some data, process it, visualize it, and then we can make better decisions, hopefully. We've seen a few examples of this, like if we have a flu or a cough or something, we may Google our symptoms, and then Google will know before governments that there is an outbreak of, you know, some symptoms or some disease or whatever. Same if we analyze millions and millions of patients' history, we may find better treatments for cancer. And it's all because there are big amounts of data that we can put in computers and basically provide better treatments. But the reality is very different. Collecting data and processing it is not necessarily as straightforward as one may think initially. There are big challenges in how we collect the data, how we process it, where to find it. There are other challenges in using different tools for aggregating the data. And basically making it useful for non-technical users. And then when we come to the visualization step, it's also it could be tricky because there are many different options that we can use. There are many different tools, many different software. And it takes a bit of practice to get to the point where you are very familiar with data visualization to choose the visualization that could be more powerful for your project. So in this talk, we're gonna talk about, or we're gonna focus on the first part, which is how do we structure data and how we organize it so it makes sense for users. And we've seen already that there could be huge opportunities like this, but in reality, when you get into practice, it's not that easy. The Google Flu Trends program shut down in 2013 because so the solution didn't work as they expected. Same for using data to find better cancer treatments. One of the most important oncology institutes in the world, they canceled a contract with Watson after spending millions and millions of dollars in a solution that at the end didn't work as expected. I don't know if you saw, but a few years back, there was this tool from Microsoft. They launched a Twitter bot, which could interact with people, and learn from what they said. So in a matter of hours, the bot started making racist comments online, all because the data that was used to train it was not that useful at the end. There was also this very cool tool, which is a tool from Google, in which users could make a drawing of let's say, a quick doodle of a bicycle, and the algorithm will tell it is a bicycle. But then if someone drew a high heel shoes, the algorithm wouldn't know it was a high heel shoe. It will guess that it was some piece of chicken or something. And that's because, usually the data that is used to train these algorithms comes with a lot of biases and a lot of things that we have to take into account, which we will talk about in this talk. And essentially what we don't want to have is something like this, where we put in some data that's dirty and not properly formatted, and then it's a big risk if we put this data into algorithms and the algorithms do not really work as expected. Please feel free to drop any questions in the chat box, or just open up your mics and we can go deeper into different parts of the talk. Just give me a second. I'm gonna. All right, so let's talk about, in this talk, we're gonna talk about big data, what it means and how is it useful. Also, we're gonna talk a lot about how to build databases manually and how to structure and clean information, and some tips and tricks along the talk, along with some tools. Okay, some misconceptions I've seen about big data. We may think that big data is something new, when in reality it's been around for a couple of decades now or more. Like the first use of algorithms was, or it still is, for instance, when we get any type of insurance. So the insurance industry has a lot of algorithms that they use for calculating fees and returns and a bunch of other metrics that they need for making insurance work. And so since the 50s, it's been a huge trend to use data to organize these algorithms. In the picture right there, you see this is a command room in Chile, where in the 70s, the president Allende he partnered up with the people who was like leading the cybernetics movement from MIT in the US, and they set up this control room, which looks more like a Stanley Kubrick movie, but in reality, it was a control room from a governmental office in Chile, where they will collect data about the output of different factories, and they will use this information to measure different parts of the economy and try to take real-time decisions. So efforts like this are not new. But what has indeed happened in the past few years is that this technology has become much more affordable and easier to implement for many different people. Now we can handle millions of records, millions of data points, and this information is becoming now more valuable and more accessible for us to make decisions. But there is a catch, and I think that when we all think about big data, we think that this information could be useful for you, for me, for people in general, for decision makers. But the reality is that when we humans make decisions, we cannot analyze or process millions of data points. That's something that's being done by machines. So at the end of the day, we humans make decisions with aggregated information, like these charts you see right here. These are charts with with few data points. Like here we have only 3 data points. In here you have as many data points as regions in your country, or if it's a timeline, maybe you have a few months or some a day, a couple of years, but at the end it's not big data. It's something much more reduced. That's what we humans are very capable of. We are very good at synthesizing and comprehending this type of information that comes in a visual formats. And so that's why when in theory we could analyze millions of data points, at the end of the day, we make decisions with very reduced size data sets. And what ends up happening is that we have many different data sets that we can use for investigations, for our analysis, for understanding public policy, for many different things, because the types of problems that we face, especially in journalism work, they're necessarily topics or sectors where data is not easy to find or not easy to aggregate. So there is a big opportunity if we get used to handling many small data sets, as we can see here. So what do you think is big data? Is it 100 gigabytes, 1 terabyte, 10 million records? What do you think? Feel free to open up mics or drop in the chat your comments. So the problem with this, trying to understand or guess what big data is, it's that we cannot really relate to these numbers. It's very difficult to really estimate what it means to have 100 gigabytes of data or 1 terabyte or 10 million records. So I have a rule of thumb, which is basically information that doesn't fit into a spreadsheet. So something that doesn't fit into a spreadsheet is it's what I call small data. Sorry, big data. And whatever fits into a spreadsheet, it's what we may call small data. So usually when you're handling big data, you may need to work with some type of programmer or IT people to help you out process all this type of information. So the good news is that there's a lot of data sets that fit into spreadsheets, and we can do a lot of things with them. Okay, so let's see some examples and how we can use manually crafted data sets for our own research and investigations. So as I mentioned, we have many, there are multiple sources of information, and oftentimes they are, they come from multiple sources. We have to deal with incompatible information, with incompatible data sets, with documents in multiple formats, and that's the type of journalistic work that's very powerful, to sit down and organize all these data sets that are very difficult to get. Even when you are not thinking about data journalism, many journalists at the end of the day end up structuring information for their investigations, even though they do not think they're doing data journalism. Sometimes just sitting down and making a list of, maybe a list of organizations, a list of sources and comments they do, it's basically a way to organize information that's very powerful for the research. So let me tell you about this project we built. This is, we helped in Colombia, the organization who was organizing all the data set about the Colombian conflict, basically 60 years of war in the country. And we, basically there were, I don't know, a lot of researchers from, political scientists, journalists, and so forth, who were collecting information from varied data sources, like reports from NGOs or press, press and news from, old archives from the 70s and the 60s, paper archives of newspapers. Then they will go to the databases that the prosecutor's office had about topics related to the Colombian conflict. So slowly, over a couple of years, they started building manually all this data about the 200,000 victims in the Colombian conflict, and organizing this data about cases and victims, and putting them in different categories for, kidnappings, sexual abuse, and massacres, and a bunch of other categories with a methodology that they came up with. So this is, as you may notice, this is a very important project which could impact thousands of families in Colombia who have lost family members, or even who have missing friends or family who have never appeared or faced forced disappearances during those years. Here on the left, you see a map that we built from those 80,000 missing persons that they're still in Colombia. Many of them were found years later in mass graves. As you can see here, this is a map of where Colombians disappeared in red, and then in green, where they were found years later in mass graves. So this is like a very powerful and impactful visual. And the whole point here is that it was only possible because many people sat down and started organizing this data manually from multiple sources. And this is the type of valuable information that could have a lot of impact. So quick question for you. What do you think are like difficult topics or any type of themes that you're usually working where data is difficult to get or difficult to find? Any ideas? You can use the chat or open up your mics, however you feel more comfortable. Okay, so I'll throw in some ideas, like topics like corruption or health or education, justice. These are the type of topics that are very difficult to find data about. And these are not the only topics. So basically anything that's socially relevant in journalism is usually very difficult to find information, or the information that does exist is not necessarily the most organized. And at the end of the day, what I've noticed is that if we look here at this is the Declaration of Human Rights. If you take any article of the Declaration of Human Rights, you see a lot of topics that are highly sensitive, highly important for all of us as citizens. And they're usually topics where the data is difficult to get, like arbitrary arrests or privacy or freedom of expression or discrimination. This type of topics is usually, there's not like a single source of information where we have the right data to make the right decisions, but rather it's a collective effort to organize this data and put it in the right format so we all can work with this data. So as I mentioned, there is small data everywhere. It could be lists that journalists compile themselves. It could be information that's in a report from an NGO. It's information that could be in a in a public database. And so let's see some examples. These are a couple of tweets from some random citizens who saw different interesting data sources, and they were sharing them online. On the left, there's a small table that shows the incarceration rates by different types of crimes in Colombia. And then on the right, you see a list of assassinations of social leaders in the country. And with this information, we were able to partner with multiple organizations. And among all of us, we started collecting information about this sensitive topic, which is social leaders being killed in the country. And unfortunately, there is not a way to know for sure what a social leader means. Like if you ask the government, they probably will not consider social leaders many people, but if you talk to social organizations, they will include many more people who is fighting for for access to water, to protect the environment, or for any type of cause. Given the nature of the conflict in Colombia, it's very risky to be a social leader, and so they get killed by basically different actors, and it's very sensitive topic, but it's also very difficult to get information from, because if you go to the United Nations, you get some information about how many social leaders are being killed, but then the prosecutor, the official numbers on the prosecutor's office, they say another thing. And so NGOs, they have a different measure of what a social leader means. So at the end, what we decided to do was to collect information from different organizations and putting them in a single database, in which we see, like, for example, this here, Victor, or you see Robinson and other names of people who were assassinated. And then we start mapping out when, who they were, what they did, what was their cause. And we make an interactive map where you can cross out where these people are being killed, and cross this information with other metrics, like the presence of narco groups or illegal mining and a bunch of other sources of information. And then in this map, you see like this region right here is very difficult for being a social leader, because there is a lot of narco traffic and cocaine plantations in there, or coke plantations, coke leaves. And so it was an interesting project because we were able to collect information from multiple sources, manually curated, reading news reports from different organizations, and then building a database and an app to web app to visualize all this information. So another example, like if you take the reports, from, the notarized report records from property ownership. This is an example of one of those reports. Basically, if you buy a house or some land in the country, you get a paper of who owned this piece of land and the history of who sold it to whom. So these are usually in paper records or PDFs, or depending on the notary that you use, it could be more digital or not. So it's very difficult to get like a proper way to organize all this information. And the real value is in when you sit down and convert this information from this list of images into something that is useful for a database. And with this, we collaborated with a news organization who built this type of interactive, which is kind of like an Instagram, but this Instagram helps you or helps the readers analyze and visualize the like the ownership and different conflicts of interest that congressmen and congresswomen have. So you pinch on one of those guys and it tells you, okay, this guy has some property here, but they are also connected with this person. They are family members with this guy who is in jail, or this type of family ties that politicians have. And this was only possible because we were able to structure the data from all these PDFs and many different other sources together with a team of journalists and researchers. And we build and transform this information that we had right here in different formats, and we were able to put it on a spreadsheet or a table, which is not big, but it's important. It has basically a couple of hundred rows, which is the number of politicians that were analyzed in this project. Cool. So do you have any questions? Okay, let's continue. So let's talk about some challenges in the data. We have cases where data does not exist. That this is usually the case of, say, vulnerable communities or people that basically are not taken into account, at different levels. And this is very difficult to track because, simply no one is making or taking record of these people or these organizations. And so it's very difficult to get access to this data. And you have to come up with ways to find data proxies, basically other databases that could allow you to measure what you're interested in. So for instance, last year we did a project with a news organization where we analyzed the gender gap in the health sector in Colombia. So basically, there is not like a single registry of all the healthcare employees in the country, but we were able to collect data on public procurement information, like public contracts, where the government hires like temporal nurses or doctors or this kind of individual contractors. And we were able to analyze how much men earned more than women in the health industry, which was very interesting. There's a question here. When analyzing huge data sets, if journalists and researchers always need to collaborate. So collaboration is very important when we have not even for huge data sets, even for small ones, if they're hard to get or organize, even if it's 50 records only, Sometimes you need to collaborate with many different people to organize this data and put it together so you can build your investigation. So it's always a good idea to collaborate with different types of people, not necessarily researchers. Sometimes is, you know, lawyers or other types of profiles that could help you with the investigations. Okay, it's also very common that we have the case where data partially exists. Basically, we have, it's very common to, even if you find the data about the topic, like, I don't know, how many, what are the CO2 emissions of Kenya overall in the past years. It may be that the data was published for some years, and then they stopped to publish it for a couple of years more. And so you have partial data to work with. Maybe coronavirus cases is a good example of that. In different countries, you have blanks in the data that you have to estimate. And so it's very tricky to have a continuous inflow of data that could help you with your investigations. There's also cases where we have bad data in good formats. I've seen this in also like in the health sector or the health industry. Take, for example, the coronavirus cases that we were discussing. I saw in countries like Colombia and Guatemala, they were publishing data about disaggregated data by state in the countries, and they will throw some numbers on a given region, but then they will put the name of the region that there were 50 cases, but that region doesn't even exist officially as a part of the country. So that's very interesting, because you have like a pretty formatted database, but at the end of the day, you cannot really use it because you have you have data that is not correct in the database, or may have data about politicians, but then they may have changed names or things like that. That makes it difficult to track to track whatever it is you want to measure. Like if you are using, for instance, you're making if you're tracking money for some, like we saw in the Pandora papers of the Panama papers, it's very difficult to get hold or reconstruct the structure of the organizations that are involved in these schemes, because usually companies change names. I saw cases where sometimes an organization will open a bank account and they will and they on purpose would put some random name in the name of the legal entity, so it could not be easily crossed with different databases. So this is the reality of working with data. Then there's also the case where we have very good data, but it comes in very bad formats. If you take any type of data about justice or legal processes, this type of data, they're usually on paper, but it's data that's very thorough and very fact-checked in a way. Like you have a lot of eyes in this data and people writing exactly facts. So it's very thorough and detailed, but it's very difficult to work with if you want to process it, and in bulk, or if you want to analyze multiple processes. You will have first to digitalize it, then parse it, then put it in a database, and it's a very time-consuming and expensive process. And then there's also the case of data that could not be used for legal reasons. Like, I don't know, sometimes the data, you could end up accessing data maybe private data that has some privacy implications, or maybe in the original contracts, say from a private entity with a government, with a public entity, it was not clear who was to own the data that was generated through the process, like say in a metro construction or things like that. It may happen that the contractors or the operators own the data, but not necessarily the public entity has access to it. And so it may be difficult to process this data. And then there are some technical challenges, what I call the Britney Spears effect. There's this very interesting data set that there are 64,000 ways for spelling Britney Spears. So you see here a couple of examples. These are basically Google searches for Britney Spears, but then you see all the different ways that it can be spelled out. So, maybe we have Washington, D.C., Washington D, that C, that other things. And so this is very real. It happens like in many different databases where you have any type of manual data input. You will very likely find cases of this Britney Spears effect, at different levels, but it could be difficult to process this data down the line. Okay, so any questions so far? Cool, just drop them on the chat. So I think there's not a very good connection. Can you hear me well? Hello, can you hear me?
Juan Pablo, I could hear you. I think it may just be China's connection. China, if you could maybe text your question in the chat.
Okay, yeah, that works. I thought it was my connection. Thanks. Okay, if you have any questions, just drop them on the chat.
I was trying to highlight that so far. No, I'm very okay. So far, the flow is very okay.
I'm not understanding the question. There's a bad connection. Maybe you can use the chat. Okay, let's continue. Good, so remember that chart at the beginning of the talk. So let's focus a little bit more on how we can organize and collect the data. So one of the, probably the most important thing that I want you to take out of this talk is this, basically that the same data set can tell multiple stories. So if you have some data set, you can have, you have many options to, visualize it, organize it, and basically tell different stories. And this is very important because usually I believe in journalism, maybe because of the printing press and how traditional publications were made years ago. We tend to have publications that are, or articles or stories that are self-contained and complete in a way. So you would, maybe put the numbers and put the whatever was accompanying your analysis inside the story, but then you forget that the data that you used for this story was also helpful. And it's very important to keep separate this data from the story you want to tell, because you may come back to this data as if it was like a person or a source, and consult it over and over again to help you with different stories. So you consult some data, you create a story, but then in the future you may have to consult it again, visualize it, analyze it, and then have another story, which is very important. So there's a question in the chat: how do you tap in data with legal challenges? I guess it's tricky. In journalism, what you have or common practice is to work with like whistleblowers, for instance, like in our case, to be able to get the data about the land ownership of different congressmen in the country. We were able to have access to different whistleblowers that help the journalist throughout the investigation. And it's because in theory, this is data that it may be public, but it's expensive to get. But then the best way is, as I mentioned before, to always collaborate. So the type of media organizations that we have seen, or a common practice, is to have some type of legal counsel that will help you sort this through. It depends on the country. Naturally, there are some countries that have some good freedom of information laws or legislation, and this helps a lot if you want to access data, especially if it's from a governmental office. Good. So as I was mentioning before, the same data set can tell multiple stories. In this case, we are seeing a very simple data set, which is some cities and the population of some cities. So here on the left, you can see a map, and you see that there is some high concentration of cities in the center right here, but you cannot really tell if this city is bigger than this city. In this city is Medellin and Cali in Colombia, but it's very difficult to see which one is bigger. But if you use this type of chart, which is a bar chart, you see that Medellin is bigger than Cali, for instance, and you see like the rank or the ranking of the cities. And then if we use this other type of visualization, which is called a tree map, you see that Bogota is as big as the next 5 cities, which is tells you a different story. So even for this very simple data set, you can, depending on how you use it, you can tell multiple stories. So this is why I mentioned before that it's very important to separate the data from the visual representation, and that's why organizing data is so important, and having a good data structure that it could help you work through many different stories that you can make using the data. Okay, I see here a question. If you have packed data or too much information, is there an application that can be used to summarize data? Yes, there is. Like the simplest option will be to do it on a spreadsheet software. We will see an example later. And there are other options online that you can use. I will show. We will see some examples later in the talk. Okay, another example. This is one of the a news app we built with an NGO in Colombia. They work with transparency, so they basically are Transparency International, and we were able to cross data that came in spreadsheets that will show the amount of money that individuals or companies were donating to political campaigns for different politicians. So in here, this is the current president of Colombia. You get to click and you see who financed this guy and how much he was given in donations for his campaign. But then we crossed out this information with another database, which is the data of public contracts. So basically, we see that this guy right here donated $25,000, but this $25,000 ended up becoming a couple of much more money that was awarded in public contracts to this donor. So this is a nice example of having small data sets, or when it could be bigger. But if you cross different data sets, it's something that's very valuable. So here are a couple of examples of headlines. These are in Spanish from newspapers. They may seem like they are fiction, but in fact they are. They happened. We have professors who got their pension, or we have a construction company winning food contracts to provide food to schools, and a bunch of other things like a city which had like 40,000 ghost students. So basically, a governor kind of invented a school, and it had 40,000 students, but the school didn't really exist, so they will get money from the central government. And this type of all of these type of examples will be tackled if we had data, like if we had the data about all schools in the country, or if we had data, easy access to data about what the companies are supposed to do, so they don't win awards or contracts with the government in other topics that they're not used to. And basically, this type of work may feel as if we are chasing ghosts, but the good news is that chasing these ghosts may oftentimes comes to how we get the right data, and we just find those in the very specific records. So actually in this example I showed you about political campaign donors, we found donors that were dead. So basically we crossed the information of donations with the civil registry, and we found that some of the donors were people who passed away before. So either we prove that there are real ghosts, and we have proof because we have them on record, or there's simply funky things going on, so politicians can get their donations in a very interesting way. Cool. Any questions so far? Okay, let's continue then. So the whole point for us to organize and structure data is because we want to treat the databases or the data tables as a source. Basically, we want to be able to interview the data. And this has to do with the questions that we were asked, like how can we summarize the data and get some reports and get some information. That's basically the process we want to do when we are doing data journalism. Basically, we want to interview the data and get answers from this data. So the thing is that to do this properly, we need to have the data clean and tidy. And I'll explain the difference of these both terms. So the main issue, or the main challenge for all of us who may be interested in getting answers from data, is to actually transform the data to the right format so it can be understood by computers. We as humans are very good at understanding data, or understanding data in different input formats and different ways, even when the data is incomplete, but computers are not, or at least not yet. So remember, we had like these notarized records on paper of land ownership. This is the type of data that's not good for computers to understand. while it's very easy for us to, so search through some pages and we can get what we're looking for. But the thing that computers are very good at is that once the data is organized in a good format and we have a lot of records, we can get the computers to help us provide answers for us. And that's why it's important to be able to transform the data in a way that in a format that computers can understand. So you probably have seen this type of data formats, like Excel sheets or CSV. Are you familiar with CSV? Has anyone of you heard of CSV before? Good. So yeah, some may have, some may not. There's some formats that computers can understand. One, like XLS or this type of formats. Excel it's very common. CSV is a way to organize data in tables, and JSON is also more or less the same, but it's more for, say, programmers. It's not so easy to understand it. So let's see. Let's look for some example of this data. And then the data here on the left is the type of formats that are good for computers to understand. And then the type of data on the right is the type of data that's not very easy for computers to understand. Think of legal records of this kind of thing is very difficult to organize this data and understand it properly. So let's say we're looking for if you're not familiar with GitHub, GitHub is one of the it's one place to have some repository of data and code for programmers. It's also a good place to search for data. Here you see I search for country codes, and then I get here a CSV file that has the country codes, a table, right? If we see at this file as a plain text file, here this is the type of data that comes in a CSV file, which is basically some tables. But in this case, let me just put this bigger. These are just tables that have some commas. So CSV stands for comma separated values. Okay, let's see if there are some other country codes. Let's look at some JSON. So here is an example of a JSON file. You can see right here. You see the name and the code, right? And this is a type of data that it's easy for a programmer or a computer to understand, but in practice it's not easy to read for us as humans. But the data is there. You have a name and a code. Okay. Good. Okay, so let's talk about data formats. We have data in percentages. We may have data in currencies, geographic coordinates, categories, and so forth. Let us create here a sample data. So have you seen or do you use Google Sheets for your work? It's kind of like Excel. I like it because everything is synced on the web. And here we may structure some data. So the good thing about spreadsheets is that you have data as tables, but then you may have you have the liberty to put anything in here. which could be messy if we want to analyze it later. So let's say name, country. This is a some simple database, JP, country, Colombia. Then we have Esther. Esther, you're based in the US, correct? And we may have now, was it Caroline from Kenya, right? If I recall right. Anyway, so this is a simple database which has, you know, some name, some country, and so forth. And in here, we can export this data in multiple formats. Here you have Excel, open document, which is for LibreOffice. We'll talk about it later. And then we have also comma separated values. We can download this here. And we can even upload it into Google Sheets and see it. Yeah, you can even upload this to Google Drive and see the CSV file directly in Google Drive. Cool. So the thing with this is that sometimes it gets tricky. Like if we input, say, this is a date, but we are not sure if this date is month, day, year, or year, day, month. Like in the US, you'll probably first will go the month, then the day, and then the year, right? But then in some other countries, like in Germany, it will be something like this, if I recall right. It's a day, so day, month, and year. And so you start seeing that this is very difficult for the computer or the spreadsheet here to understand, right? So we have different dates in different formats, and it's not clear that we can use this. If we go with numbers, we may have the same issue. In some countries, you will use the dot as a decimal separator, but in some countries you may have the comma, right? And in here, this could lead to many different errors when we compute or make analysis on the data. So you go here, you see the sum right here is not, if we want to add some, well, we want to add some numbers, we want to make sure that we always use the commas and the decimals for structuring the data. Say for something that could be a percentage, put this bigger. And so a percentage could be like 10% could be understood as 0.1, but same for this. And if we mix these in the same table, this is tricky or could be a problem later. So there's a good way here to get, I think there's, let me see if this is working. Yeah, okay. If you go to the settings, you can change the, since I'm not signed in, I cannot do it right now. But if you go to settings, you can change the locale, which is basically how you tell computers which formats to use. You can even change the formats of the data right here. Numbers for your financial dates, different types of dates, and so forth. And so it's very useful to stick to the correct formats for doing your data analysis. Cool. So as you can see, we have many different options, like say geographic coordinates. Refresh. Sometimes you find coordinates like this. Which is latitude and longitude, but then you might have this also in degrees. I don't have the degree symbol, but then you get the idea. So it is rather complicated to be consistent with this type of data, especially if you didn't create the data yourself. You will often find data that comes in multiple formats, and it's very important to parse this data and organize it properly. Good. So let's talk about why it's important to have tabular data. So when we talk about tabular, it refers to data that comes as tables. So here we have a very simple table. We have a first name, last name, age, and salary. And we see that this table has, a heading. So some titles for the columns, and then you have the data here. This is another example of a table, of a data table, but this is very different from the first one or the one before. In this case, we have here you have totals, we have headings for the years, we have headings for units and orders, we have a salesperson and a country, we have some, lines and things in bold that we're going to highlight. So in reality, this is data that's good, that's well structured for analysis, but this type of data is not that well structured for analysis. We'll see why in a minute, but this type of representation is more like a visualization of the data. So it's a good way to put the data so I can read it and have some, information about totals and so forth. But it's not necessarily something simple that we can use to make computations in a spreadsheet. Like if we are here and we want to add the numbers, we will just, as you know, you probably have, we can add a sum of these numbers right here. And then we have the total is 18, right? This is something we can do with a spreadsheet. Same, if we highlight here, you see that the sum down in the corner, it shows the sum or the total. But sometimes it may happen that we drag and we end up counting twice the totals. So this is, it's good practice not to have totals directly in the database that you wanna analyze, but rather have this data structured in a way so totals and results from the data, you are not computing them right here. Good. So what is tidy data and clean data? Remember? So when cleaning data, it's important to have consistent categories like male or female, and not missing that with M or F, right? So it's very important to have consistent categories for the data we're using. Maybe here, maybe we have another person, which was, not sure, maybe like if maybe Kenya with an I is some mistake that someone could do or could write, and then we have two different categories for the same thing that we want to count. So this is something that we don't want in our database. Same for here, we don't want to mix formats for dates. We don't want to mix formats for percentages. And this is fine. We have different names. Okay. So it's important to be consistent with the categories. and the date formats and the numeric values, as we saw. Good. Quick question for you. How many variables do you see here? Any ideas? Nope. Okay, maybe we have, okay, Caroline says 2. What will be the name of these variables? Caroline? You know, maybe we can have, yeah, correct. We can have some size, and then what will be the other variable? Any ideas? Any guess is fine. Okay, so that's the issue. We have like these 2 variables. We have, this could be a size, you know, but then we have some quantity, correct? But we don't know which type of quantity there is, right? We don't know, is it, I don't know, cars? Is it cities? Is it people? Is it, what is it that we're counting here? We don't know. And this is an example of a data set that is clean, but that is not tidy. So let's see an example here. Say we have, I don't know, country. And then we have, I don't know, income. Well, let's do it by year. 2010, 2012, 2013. And then we have some numbers. Cool. So what are the variables here? What do you think? We have a country, good. First variable. And then we have income, which could come. You will know that we were talking about income, right? So we don't know this income, is it income in what currency? We don't know anything. So it's this type of data set. It's very common, but it's well organized, but it is data that is not necessarily tidy. So if we were to have this data like in a tidy format, we will have to spell out the variables we want explicitly. So we have country, we have year, which is at the end, this column is a year, and then we have say income, for instance, or some quantity, and then we have country, year. So let me just copy this, and I can go here and go to edit, paste special, and then I can go paste transposed, and you see that this thing that was horizontal now is pasted vertically. And same for income. So we can have this income for this, and then want to make sure that we have the right numbers. This is for 2011, then this is for 2012, and I can just put this here. So you get the idea. This is a table that where we have now explicit values for our data set, and this is easier for us to make calculations on. Good. Another example. How many variables do you see here? Then we have religion, and then we have, yeah, maybe income or something like that. And then we have some counts or things that we don't know what they are. So when looking at this data, this is data that is tidy, but this is data that is not tidy. Okay. So what are the properties of having tidy data? So every variable must be one column. In this example, we have the years in multiple columns. So this is an indication that the data is not properly formatted for analysis. It may be good to put this data in a report, which is completely fine. But if we want to analyze it, it's easier if we do it like this. That's because, it's easier to make computations on this data than on this data, and I'll show you in a minute. Okay, every column must have the same data type. So here we have all numbers, which is fine. Here we have all countries, all years, all numbers. So this is fine. And every new observation must be included in a new row. So basically, we have a new year, we will have to go here and put 2013, and we will have to add new rows, which is what we want. And then we can just copy paste here. There we go. We have new years of information, and then we add new rows. When we have data that is not tidy, we will have to add a new column, right? And this is an indication that the data is not well formatted. So if we have a new data point, we shouldn't be adding more columns to our data set. So I don't know if you've heard, but in the UK, they had a data set about coronavirus cases, and eventually their spreadsheet ran out of columns. So they started inputting data about coronavirus cases in a spreadsheet, and at the end, they didn't have enough columns to put more data. So that caused a bit of an issue while syncing data of coronavirus cases in the whole country, because they were not integrating the data properly. Good. Some more tips. Headings in only one row. So here we have, this is good. This is okay because we have only one heading on a row, but we may have the case of, I don't know, say male, female, and then we have 2 years. So in this small table, we have sometimes, like if you have to merge columns like this or cells like this in your spreadsheet, it's usually an indication that your data is not well formatted for analysis. As I mentioned, it's okay to have this as a representation of data for communication purposes, but if you want to sit down and analyze it, it's better if you have the data in this tidy format. If you have something like this, it's an indication that your data is not well formatted for analysis, because we have 2 headings here. We have one heading for gender, say, and then we have another for the years. I'll just move this down here. So a way to have this data in a tidy format, we should have the variables, which could be gender. Then we have male and female. Then we have the year, maybe 2011. So male and female for 2011 and male and female for 2012. And maybe you have a quantity. So note that I have to guess that this is a quantity or some value or whatever, or category. It will be some category. Maybe this is high, low, high, and so forth. Because if we have the data like this, it may be clean, but it's not tidy because we don't understand what all variables mean instantly. But here we understand that we have a gender, a year, and a category. So they are spelled out explicitly, the data, and what the columns of information mean. Okay, in this case, we have hidden variables because we don't know exactly what this means unless I tell you what it is, say income or whatever. It's very difficult to guess what it is from the table itself. And again, if you have new data, it's better to include new rows. Good. Perfect. So what happens when you have multiple tables? So you want to organize them in a way that you have for every single tab, everything talks about one thing. Say in this case, it's countries. In this case, it's gender. So you better have different tables for different types of entities that you want to analyze. Good. Can you spot some issues with this data set? Right here. Okay, some quick notes. You see here that we are mixing date formats. Yes, this is not good practice. Then we have very subtle things like we have Mexico and Mexico with an accent. These are the type of things that happen when you have manual data input, and that it could be a problem. Same for other categories like the nationality. You see Mexico and Mexican, it's probably the same category. So you want to make sure they're consistent. And this is the reality when we are working with data. There's a question if names should be separated. Yes, it's good practice too, but it really depends on the application. It's not strictly necessary to separate it first, but if it makes sense for your application, perhaps you want to see people who have the same last names, it could make sense. Like we did that for that case of analyzing the family ties of congressmen. So we had to know their last names to see if we were able to track some family members with whom they were doing businesses. Good. I already showed you this. Basically, when we have the data in this format, it's what is called a wide data formats. Basically, the more data we have, we should add more columns. But as I explained, it's better if you add new rows to the data set. So the proper way to organize this data set is by doing what I showed you before, which is in this case, this table, you wouldn't know what it is unless I told you that this is tuberculosis cases. So we have a country code. Remember, we were looking for country codes before. We have some of them right here, like Afghanistan, and then we can see it here. We have a year, and then we have some demographic information like male and female and different age ranges. So this is like a mix of variables. So remember that each variable should only be in one column. And here we have a single variable spanning over multiple columns, which is not good practice. So the best way to organize this data is by this. We just copy paste and we transform these columns, these names of the variables into a new categories in a new variable, which is called demographic. And then we have some cases. And another example, we were creating this database of some meanings of some words. And when we had a new meaning, we will have to add a new column for that meaning of that word, which is, as you can imagine, we have to add new columns every time we get a new word. And it's this is an indication that the data is not well formatted. The best way is to put the data in a long format, basically downwards. When we have new observations, we simply add new rows to our data set. But unfortunately, many real life data that we find in reports, or when you ask for data for a public organization and so forth, they will probably give you data like this. So you will have to transform it. In here we have like age group from different ages, and note that we have totals, which could be a problem eventually if we want to analyze this data in a spreadsheet. Okay, so why is this important? I know this could be like difficult to grasp. It comes with practice, but the good option, or the whole idea for having this data like this, is so we can interview the data, right? As I mentioned in the beginning. So let's look at an example. So this is a report from a news organization in the US. It's called Mother Jones. And I was working real briefly with them. And they had this story, very interesting and long one, about the connections of Trump with Russia, or the ties that Trump had with Russia. So here you see, in '88, maybe Trump met Gorbachev in New York, and then in '89 they did some events and the Trump Tower and whatever. So the journalists were tracking all these points in time where Trump had some sort of connection with Russia, and it's a very interesting read, but unfortunately it's not in a format that we can use to interview it fast. So if we have questions like how many times a specific person, say Carter Page, was involved in the whole story, you will have to read the story over and over and take notes so you have the right answer. Or how many Russian ambassadors were involved, or which type of connection was used the most. These type of questions are questions that you will have to read the whole story every time you have a question for you to answer with this data. So what one could do is structure this data in a way that we can use it for making queries that we can answer very easily. So for example, if we're interested in the connections of Trump with Russia, now we have like a structure where we have one person, we have a second person, and we have the type of relationship and maybe the date of that relationship. But we also may have to add properties to all the organizations and people involved. And in this case, you have this guy is from Russia, and he was a Russian ambassador. Then you had another guy, Vitaly Chukin, from Russia, who was also a diplomat, and so forth. So note that when we have this data in a spreadsheet, it's way easier to answer this type of questions. So all we have to do is a filter, or maybe doing some counts, and we have all the we can answer many of the questions we have around this specific topic if we have the data properly formatted. So important things to keep in mind when interviewing the data is make a list of questions that you want to answer with the data you have. You can make totals, calculations, and aggregations, and then you will have out of the box many different answers to your data. So say here, maybe what's the average value, what the average income for all countries in 2009, sorry, in 2011. we can easily calculate it here. We have the average. So what's the total? We have the total right here. What's the count, and so forth. So these are many different questions that we can answer once we have the some data like this, right? Then we can make pivot tables. So I'm not that familiar with pivot tables. I personally myself do it programming, but then we can do things like this. We go to tools. Is it? Let me remember. Yeah, we can add filters. I don't think. Yeah, I don't think I can do it right now because I'm not logged in. But you can create different filters on the data and different cross tabulations that can help you filter through the data and answer the questions that you want. Like, what's the max amount of income through all the years? And then you have here the answer, which is 25 something. All right. Do you have any questions? Okay, good. So now let's talk a bit about some examples or some tools. Here, this is a data visualization we did from another case where we use this type of approach of structuring data. We used database for so we built together with many different news organizations in Latin America from different countries, 7 different countries. We collected information of public procurement about emergency contracts in the pandemic. So basically, the governments were buying, masks or different equipment, or doing many different types of contracts to tackle the pandemic. And in this case, we collected information from contracts that were from PDFs, from Excel sheets, from many different sources in different countries. And we collected all this information in a single database that was curated manually from many different journalists who were collaborating. And we built an interactive report that was a transnational publication. And this table right here is one of the tables we were able to collect and organize. This is a table about tests or COVID tests that were applied in different countries in Latin America. So here you have the names of the companies that were providing different tests, and which type of tests there were, and which companies were involved in providing these tests in different countries. So we see like many companies from China, others from the US, from Switzerland, and other countries who were selling COVID tests in different countries in Latin America. So as you may have guessed by now, this type of data is not like data that exists in a database already. So it's not like there is a single database of providers of COVID tests for all over the world. So basically we had to build this data from multiple organizations, like, exports and imports, information systems from different countries, from reports, from the public contracts, and so forth. And this is information that was manually curated. So in here you can see the type of tests and different categories. We made sure that we spell out molecular consistently throughout the whole database. And something that really helps is to having a data dictionary, which is basically the variable that we're using, and some description, because sometimes it's not enough to have the name of the variable right here. Remember that we only want to have one heading for this database. And this is a real case of a publication we did with this data set. Okay, another data set that we built manually was this about femicides in the country. Basically, from different news reports, we manually collected information of victims, where they were located, where they were, when they were killed for gender reasons, and a bunch of other things. So this was particularly important in our context, because even though we have a law for femicides in the country, or basically it's a felony, we don't have official numbers on women killed by gender reasons in the country. So we had to build this database from scratch, from different sources, including news reports. And from this, we were able to build this type of, charts or interactives. It's very, you can build charts directly on Google Sheets by simply going to the options. Sorry, you can go to insert here, chart, and then let's do something here quickly. Okay, I found it. Insert chart, and then you have the chart automatically from the data that you wanted to analyze. So this is helpful if you want to check the data, if you want to make some quick analysis on the data. Then there is we can also do things like this: insert pivot table. Let's put it on a new sheet, and here it asks you which type of variables to put in rows and columns. So basically this does the tabulations of the data, say country, and then we have some country, and maybe we can use the income to see a total income by year. Sorry, this is not what I wanted, but let's try values income, and then we have the totals by country, right? And this is the type of aggregations that we can do when we have the data formatted like this, instead of when you have the data like this. Okay. Good. And with this type of data organized, we can make this type of charts to understand what are the trends in the specific investigation we're making. Now, yeah, with this data, we were able to build different interactives and data visualizations. And this helps organizing and visualizing the data. Good. So the first and most important tool to use are spreadsheets when we are using data for our investigations. And Excel is one of them. Then there's Google Sheets, as I have been using in the browser. And then this very important is LibreOffice, which is like an open source alternative to Excel. And it has the advantage that it doesn't mess up the data when we have like accents or this kind of thing that sometimes in Excel are difficult to handle. Good. Then there's other tool which called Airtable. I'm just gonna go here and show you this tool. This is very helpful and very useful if you wanna organize data and manually in a database. You see here you have some examples. You can make some visualizations, but the most important part is that you have different ways of organizing the data as tables and spreadsheets. You have here, yeah, an example. You can add different columns, and in the columns you can add attachments. You can make some filters, like, okay, I want to see all the only this category in this data set. Then you can have multiple databases or multiple tabs, and you can link them one to the next, like in here. it's very difficult for us to be consistent on the names of the variables. Maybe we can have a new column here with countries. And we put some countries, but it's very difficult to link this specific value of this country with this specific value of the country in this other table. This is something that's not very easy to do in spreadsheets, but with Airtable is very easy to use. It's not, it's free up to 1,000 records, so it will be useful for many applications, because we, as I mentioned, there are many times where we use simple tools or simple data or not big data, and so it should work. And then there are some praised plans for other things. This example that I'm showing right here is the database we built for the case of social leaders being killed. And then we can personalize this with date formats, with different categories. So you make sure that you don't spell out the different categories with different, or you put the same categories with different spellings, as we have seen. So it's very useful. And then we have Tabula, which is a very important tool that helps you extract data from PDFs. So if you have tables, PDF tables directly in your PDFs, it's a tool that you can install. You just go search for Tabula PDF, and then you get this web page, and it tells you, maybe I installed this thing, and you can use this software by simply uploading a PDF, and then you are able to extract tables out of this PDF with this tool. Good. There are other tools that are very helpful when visualizing data. One of them is just using Notepad or text editors that allow you to see the data as is. Basically, if there are text files, you can see them exactly like this, and you can edit them right in your computer. So sometimes it's useful if you want to see how the data is formatted, like originally, and then you can even copy paste all these values automatically directly in a text editor that you can then paste into a spreadsheet, for instance, here. Good. And finally, I'm going to show you quickly some of our tools. You go to DataSketch.co. Sorry, I'm gonna change here my language to English. Good. And then in DataSketch, you just go there, create an account, and we have many different tools to help you process your data. If you have it in spreadsheets or different files, you can just go here and organize and visualize some data. So say I'm looking for a PDF solution. Maybe we have this tool that allows you to upload some PDFs and get some data from there. Maybe we have the gender from name app. Yeah, there are many different tools for making maps over different cities, some countries. We are slowly adding different countries, like maybe Kenya. We could do it. So if you guys ever need it, just send me an email and we will prioritize it and upload it here, so you can make maps of Kenya with our tools. This is an example of a tool to extract texts from PDFs. Let me see if I have some PDF here. See, I uploaded a PDF here. And automatically I get all the text parts from this PDF that I uploaded. Okay, so then you can download this as doc or text file or something if you wanna, maybe search in this document later. Same here. Say you have some data set, like as I mentioned before, we were analyzing like congressmen. We have maybe a congressperson named Carolina, and then it will automatically suggest that this person is female. So we have done this analysis for, or this tool to help clean and organize data that manually is very difficult to organize. So you paste here like a list of contractors, a list of politicians, and then you can make some gender gap analysis faster. Okay, so yeah, I guess that's it. We still have a few minutes to answer some questions or discuss some of the things that we have talked about here. So feel free to drop a line. I'll send my email I put my email in the chat, and if you ever need any help or have any questions, just send me an email. Okay, any questions?
Actually, I do. Several slides ago, I noticed that in one of the graphs you had, there were, I think it was like print, internet, some cells had print only. I was just curious to know, like, in my head, I'm thinking each cell should just have one data.
Yes, that's a good question. Yes,
yeah,
that might be the case. It depends on the application. So if you are interested in the individual medium, that for the medium, in this case print or internet, then it's a good idea to split it and have like print or internet and just mark as they have. And but yeah, this is optional.
Are there other questions, whether in the chat or take yourself off mute? We do have a few minutes available. And while you do that, you may have also noticed that I dropped in the chat box also a very, very quick evaluation. Now, of course, after participating in this, I'm going to look at the evaluation to make sure that the data we're getting makes sense and organized in such a way. But does anybody have any questions? Okay, well, thank you, JP, for dropping your email address in the chat. This is an invitation for folks to go ahead and connect with him directly. And you saw just the amazing things that he has on his website. So I certainly will be taking advantage of that and looking in that. And I will always remember to tidy before I clean with the data.
Good.
So with that, I want to thank. So with that, I just want to thank Juan, Pablo for his expertise, his thoughts, his practical advice. This is truly a helpful training, and so I want to give space and voice of appreciation for that. CCIJ continues to provide trainings. We will have another one November 8th, which is actually referring to an earlier question or a comment that was made, which is about the idea of journalism and data science. How do they work collaboratively? How do they work together? So we'll be having a special training around that approach on December 8th, excuse me. So please stay tuned for that information there. So again, on behalf of CCIJ, I just want to thank everybody for participating. We do have this recorded. We will make that available for folks who were unable to join it and for you to rewatch. Again, thank you, Juan Pablo. Much appreciated. Everybody else, have a wonderful rest of the day and evening. Goodbye, everybody.
Thank you. Bye-bye.